Hello, this is Mrs. Lewis again with today's lesson on how to charge objects using friction and induction. When two objects are charged by friction, the electrons are going to move from one object to the other. We know that when we do this rubbing, the object with the higher electron affinity is the one that gets the electrons. Here's an example. If we rub a rubber rod with animal fur, the rod has a greater electron affinity. It gets the electrons and becomes negatively charged. The fur loses the electrons and becomes positively charged. We can predict what object will be negative and what object will be positive using this series called the triboelectric series. Items that are at the top of the list have a higher electron affinity. That means that they're going to be the ones that grab the electrons. So if we rub two items together from this list, the item that's higher on the list will be negative. So if we take rubber and we rub it with wool, rubber is higher on the list, so it will be negative because it'll grab the electrons from the wool. If we took amber and we rubbed it with silk, the amber would take the electrons because it's higher on the list, and it would become negatively charged, and the silk would become positively charged. When we use friction to charge objects, the total charge is conserved. So let's look at this situation. Here we have somebody who's going to transfer some electrons by combing their hair. And when they comb their hair, they're going to use friction to charge the substances. So before the combing, here's a situation before the combing. And here we have a piece of hair, and it's got 3 positive charges, 3 negative charges. So the net charge is 0. Here's the comb. The comb has 3 positive charges, 3 negative charges. The net charge is 0. After the combing, the electrons have been moved. So during the friction, the electrons are going to be moved. And over here in the hair now, we have 3 positive charges, and we have 1 negative charge. So we have a net charge of -2. And here on the comb, we have 3 positive charges, but 5 negative charges. So we have a net charge of -2. So here on the hair, we have a charge of positive because the hair has lost the electrons, and so we have a +2 charge. Here on the comb has gained the electrons, so it has a negative charge, a -2. But the +2 and the -2 add together, the charge is conserved, and it's still 0. Another way to charge substances is by induction. Here's an example of how this works. To start off with, we have 2 metal spheres, A and B, and they are touching each other, but they're on top of an insulator, and so the insulator is going to help keep any charges on these spheres. All right, these 2 spheres are sitting here, and then we're going to take a negatively charged balloon, and we're going to bring it near the 2 spheres. When we do that, the positive charges are going to collect over here, and the negative charges are going to collect over here, and so we will have polarized the 2 spheres. This one having the positive charge because it's going to be attracted to this negative charge, and then this one being left with the negative charge. Okay, then we're going to pull the 2 spheres apart, And when we pull the two spheres apart, since these are metals, these are conductors, the charge is going to evenly distribute itself. And now we have a positively charged sphere and a negatively charged sphere. The insulator down here is going to prevent the electrons from moving, and we've charged these two spheres by induction. When we charge by induction, the substance that we use for charging does not touch the spheres. Here we have a similar situation. We have our two metal spheres here, and they're sitting on top of insulators, but they're touching each other, so therefore charges can move back and forth between these two spheres. This time, we're going to bring a positively charged balloon near the first sphere. That's going to cause the electrons to move over this way because they're going to be attracted by this positive charge, and they're going to accumulate here on sphere A, and they're going to vacate sphere B, so it's going to have a positive charge. And then we're going to separate these two spheres, and after we separate them, the charge, since these are conductors, is going to distribute itself evenly, and we're going to end up with one sphere here that has a negative charge and one sphere here that has a positive charge. We've charged it by induction. We used this balloon. We brought it close to the spheres. We didn't touch them, but the spheres were touching, so the charges and the electrons could move back and forth between the two spheres. We could set something like this up in class, and we could charge two pop cans by induction. So here is a similar situation. Here we have two cola cans. They're sitting on top of some insulator, and we have a negatively charged balloon here. So that means that the positive charge is going to accumulate over here because the electrons will have moved away from that negative charge here. So the electrons have moved over here and have left this cola can with a positive charge. They've accumulated over here, and they've given this cola can a negative charge. Then we'd separate the two cola cans, and the charges would distribute themselves, and we'd have one positively charged cola can and one negatively charged cola can. And this is charging by induction. During induction, it's important to remember that the object does not get a charge as a result of having the charge come in from this item here, which is causing the effect. Okay, so these two spheres here, the same situation is going to occur. We have a charged ruler that has a negative charge. We have these two spheres that are touching, and the electrons are going to move away. They can transfer from one sphere to the other. They move away because they want to get away from this charged item, but it doesn't touch. There's no touching here. And then when we separate the two spheres, the charges distribute themselves evenly, and we have a positively charged sphere and a negatively charged sphere. When we charge by friction, that's a different situation. The charge on the object results from electron moving from one originally neutral substance to the other originally neutral substance. So here we have a cloth, and that cloth is going to rub this acetate rod. When the cloth rubs the acetate rod, the electrons move into the cloth from the rod, and when they move into the cloth from the rod, they don't have as many electrons here, so the acetate rod has a positive 3 charge, and the cloth has a negative 3 charge because it's gotten the electrons. We're not really talking about like the movement of 3 electrons here, but this is just like a unit of charge, but millions of electrons are moving to give this unit of charge. It's like a coulomb, which is a very, very large number of electrons. So Another thing to think about here is if we want to just charge a single sphere, we're going to have something called a ground. Because we're going to have to give some place for those electrons to go because we only have one sphere. So here we have one metal sphere sitting on top of some styrofoam or some kind of an insulator, and we're going to bring our negatively charged balloon near it, not touching it, but near it. That's going to cause the electrons to run over to as far as they can to the other side of this sphere, but they're still stuck in the sphere until we add a ground. And our finger can be a ground. So if we touch this side of the sphere with our finger, we're going to provide a place for the electrons to run away from that sphere. And when they do that, the sphere is going to be positively charged. And since it's a conductor, that positive charge is going to get evenly distributed. So with the use of a ground, and the ground here is our finger, we have a place to pull the electrons away, and we can end up charging just one sphere. Another apparatus that we're going to make in class is called an electrophorus. And the electrophorus also operates by the induction process. So we'll be doing this in class. First of all, we're going to take a styrofoam plate, and we're going to rub it with some fur, and that's going to cause the electrons to move from the fur into the styrofoam, and they're going to be stuck there. And then we're going to take an aluminum plate, which we have put a styrofoam cup. We've taped a styrofoam cup to it so we can touch the styrofoam cup without moving the electrons. And we're going to take that aluminum plate and we're going to bring it near this negatively charged styrofoam. Okay. Then we're going to take, that's going to make the electrons move up to the rim of the aluminum plate. Can't get out though, just moved up to the rim. But then we're going to add a ground. We're going to touch the rim with our finger. And when we do that, the electrons that are wanting to get away are going to travel down our arm. And we're going to end up having a positive charge on that plate. And then, after a little bit of time, that positive charge will evenly distribute itself, and we will have gotten a charge onto this aluminum plate by induction. And this is called an electrophorus. We can add more and more charge to this.